Hello everyone, this is Meghana. In this video, let's learn about physical layer in computer networks, which is taken from the subject of computer networks, which bears a course code of 21 CS 52. So let's get started. So let's have an introduction to physical layer, where it is the lowest layer of OSI module and is responsible for the physical transmission of data over a network, and also it plays a main role in ensuring reliable and efficient communication between the devices in a network. The next is, what is physical layer in computer networks? The physical layer is the first and also the lowest layer in the OSI model of computer networks, and also it is responsible for the transmission and reception of raw bit streams over a physical medium such as copper wires or optical fibers. The main purpose of the physical layer is to establish and maintain the physical connection between the network devices and also to ensure reliable and efficient data transfer. How the physical layers are going to function. The first one is encoding and decoding, where the physical layer is responsible for converting the digital data into signals that can be transmitted over the network. This includes encoding the data into a format suitable for transmission and decoding the received signals back into the digital data. The next one is error detection and correction. The physical layer also performs error detection and correction to ensure the integrity of the data transmitted over the network. It includes mechanism to detect and correct errors that may occur during transmission, such as noises or interfaces. Signal transmission. The physical layer is responsible for the transmitting the encoded data signal over a network medium, and also it includes defining the electrical, mechanical and timing characteristics of the transmission medium to ensure reliable signal transmission. Modulation techniques in a physical layer. There are three modulation techniques. The first one is amplitude modulation, next is a frequency modulation, then a phase modulation. Amplitude modulation is a technique where amplitude of a carrier wave is varied in a proportion to the waveform being transmitted. It is commonly used in radio broadcasting. Frequency modulation is a technique in which the frequency of a carrier wave is varied in proportion to the waveform being transmitted. It is commonly used in radio broadcasting and also in a two-way communication system. Phase modulation, where it's basically used in a carrier wave, is varied where in a proportion to a waveform being transmitted, and it is commonly used in a digital communication system. Transmission media. The physical layer of computer networks utilizes various types of transmission media in order to transmit the data between devices. These transmission media play a crucial role in establishing reliable and efficient communication. The most commonly used transmission media includes a twisted pair, coaxial cable and fiber optics. Like, what is a twisted pair? It's a physical media where it consists of two insulated copper wires which are twisted together and commonly used for Ethernet networks. And the main advantages of these twisted pair are these are in like low cost, flexibility, having a more flexibility, easy installation, and the disadvantage is the limited bandwidth produced in this and susceptible to interferences. The next one is coaxial cable, which consists of a central conductor surrounded by an insulator, a metallic shield and an outer insulation layer, which is having an advantage of a higher bandwidth, better signal quality, and it can be fed into a longer distance. The main disadvantage is like because of thicker and also there is a less flexibility. more expensive than the twisted pair. The next one is fiber optics, where it uses a thin strands of glass or a plastic in order to transmit the data as a pulse of light, where the main advantage is like it's having a high bandwidth, and also it can be fed into a longer distance transmission, and immune to electromagnetic interfaces. The main disadvantage is high cost and more complex installation and maintenance. Data encoding. The data encoding in a physical layer includes a Manchester encoding, differential Manchester encoding, and NZ encoding. Each bit is represented by a transition from high to low or low to high. And also in Manchester encoding, which provides a synchronization between the sender and also with the receiver. Differential Manchester encoding consists where each bit is represented by a transition at the middle of the bit period, ensures a synchronization and provides better error detection and than Manchester encoding. Whereas in NZ encoding, each bit is represented by a fixed voltage level, a simpler encoding schema, but more susceptible to errors and synchronization issues. How is the signal transmission in physical layer? It can be conducted in two ways, that is a modulation techniques and a signal propagation. In modulation techniques, in the physical layer, signals are transmitted using modulation techniques in which that encodes the data into carrier waves. These technique includes, as we have explained in the previous slides, amplitude modification, modulation, frequency modulation, and also a phase modulation. Whereas in signal propagation includes a transmission of signals through a physical medium such as a copper wire or optical fibers, where we gave example in previous slides like twisted pair, coaxial wire, etc. The quality of signal propagation can be affected by the factors like attenuation, interference, and also for noises, which mean to be unwanted signals. The next one is error detection and correction in a physical layer. Partiality check and also through a checksum, and the last one is through a cyclic redundancy check, where partially check is a simple error detection technique used in a physical layer of computer networks. It involves adding an extra bit called a partiary bit into the group of bits being transmitted. The value of partiary bit is chosen so that the total number of ones in the group of bits include the partiary bit is either even or odd. At the receiver end, the partiary of the received bits is checked. If the received partiary is different from the expected partiary, an error is detected. The next one is checksum. Is another error detection technique used in a physical layer, in which it involves summing up all the data bit being transmitted and adding this sum as an extra field in the transmitted messages. At the receiver end, the checksum is recalculated using the received data bits. If the recalculated checksum is different from the received checksum, an error is detected. And also for CRC is more advanced error detection technique used in a physical layer. It involves dividing the data bits by a predetermined divisor using a polynomial division. The remainder of the division is then added as an extra field in the transmitted messages. At the receiver end, the receiver data bits are divided by the same divisor. If the remainder of the division is not 0, then the error is detected. What are the devices we use in physical layer? The first one is a repeaters, hubs, and NICs, which is network interface cards. Repeaters are the devices used to regenerate or amplify signals in order to extend the reach of a network. They are commonly used in Ethernet networks in order to overcome the signal regeneration over a long distance. Hubs are the devices which are connected multiple devices in a network, allowing them to communicate with each other. They operate at a physical layer of the network and also are responsible for the signal amplification and distribution to connected devices. And the next one is NICs, where they are the hardware devices that enable computer or other devices to connect to the network, and also allowing them for the transmission and also for reception of data. Here is a diagram of a physical layer standards, how the data rate is explained here. Basically, it is dependent on the Ethernet Wi-Fi, where Ethernet is widely used physical layer standards in computer networks, providing data rate is up to 1000 Mbps, whereas Wi-Fi is a wireless physical layer standard that enables a high-speed data transmission with a data rate of 866 Mbps. Whereas in Bluetooth, it's a short-range wireless physical layer commonly used for connecting devices such as smartphones or headphones with a data rate up to 3 Mbps. At last, we can conclude that the physical layer is a crucial component of computer networks which are responsible for the transmission and reception of data signals. Throughout this presentation, we have discussed key points related to the physical layer, including the physical layer is the lowest layer of OSI model and providing the physical means of transmitting data, and also it involves the use of physical media such as cables or wireless signals in order to transmit the data. The physical layer is also responsible for encoding and decoding the data into electrical, optical or radio signals, and also it ensures reliable transmission by detecting and correcting the errors. So in conclusion, understanding the importance of physical layer is essential for the computer administration and professional working in the field of computer science. It forms the foundation for communication and data transmission by enabling the seamless operation of networks. Thank you for watching the video.